Everybody high. To truly understand the power of rhythmic breathing, one must view it within the broader context of the body's nervous and regulatory systems. While anatomy textbooks depict the autonomic branches, sympathetic and parasympathetic, the somatic nervous system, intrinsic neural networks like those in the heart and gut, and humoral endocrine regulation, as distinct functionally they act as a single coordinated orchestra. The quality of this orchestral performance largely determines an individual's health, physiological reserves, and resilience against disease. Heart rhythm regulation serves as the perfect lens through which to view this coordination. If one examines a time series of cardiac cycles where each bar represents an RR interval, the length of the cycle fluctuates beat to beat. This variation is not random. It is the result of multiple conducting forces, sympathetic and parasympathetic activity, intrinsic cardiac reflexes, and humoral influences. This sequence of intervals forms a wave function that can be decomposed, much like a prism splits light, using a mathematical tool called the fast Fourier transform. This process reveals a spectrum of regulatory frequencies: low frequency, slow regulation, primarily associated with humoral and long latency mechanism, mid-frequency regulation associated with sympathetic activity, and high-frequency fast regulation associated with the rapidly acting parasympathetic system. I emphasize the parasympathetic component as a critical buffer of necessary mechanical play within the system. A useful analogy is the slight looseness introduced into the nose wheel mechanism of early jet aircraft to prevent rigid impact crashes during landing. By allowing rapid, fine, and reversible adjustments, the parasympathetic system provides the flexibility required for safe and adaptive navigation through physiological stress. This functional flexibility has an anatomical basis. In the brainstem, parasympathetic nuclei are located in close proximity to respiratory centers. Consequently, respiratory rhythm continuously stimulates these parasympathetic areas. Rhythmic breathing, whereas guided by metronome or generated naturally during cyclic physical activity, act as driver for these nuclei, directly increasing the power of the high-frequency fast regulatory component. Spectral analysis confirms that during rhythmic breathing, there is a marked increase in the high-frequency band, reflecting a strengthened fast regulatory capacity. By training the interaction between respiratory centers and parasympathetic nuclei, we improve the coherence and power of the entire regulatory orchestra. Whether implemented through specific breathing exercises or rhythmic physiological exertion, this practice ensures that the body's distinct regulatory link works in concert, creating the most favorable internal conditions for health and longevity. Thanks for likes and sharing.